So as requested, here is a video for numbers 5 and 6 from this worksheet. So number 5, let's get a bigger sheet of paper, says to find the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. So in order to get a visual of this, to graph this, we should get this into y equals form. Okay, so here if I add y squared to the left and subtract x to the right, and so y equals, I'll take the square root, so plus or minus 3 minus x, square root of 3 minus x. And then here I could subtract 1 to the other side, so I get y equals x minus 1. Okay, so here's something I can work with. So now, I'll draw my xy axis. If this is radical 3 minus x, well, I know if this was positive x, square root of 3, I would go to the left by 3 and go this way. But since it's negative x, I'm reflecting over the y-axis, so I'm going this way. And then the negation of that would be the opposite way. And so here is my first graph for this guy. And we expected it to look like a sideways parabola because it originally is y squared. And then x minus 1. Oh, I know I'm going down 1. And so it's something like this. So we need the region bounded by these two graphs. And I can see that region is in here. I can shade it. So that's this region right in here, where I have this line and this curve. So there's my region. So I need to get these two values where they intersect. So I have my limits of integration. Since this is all about y, and I can see this would be right minus left, I need to get my y values of intersection. So I'll take the original equations, 3 minus y squared equals y plus 1, so I can get my points of intersection. So I end up with, if I add y to the other side, I get y squared plus y, I subtract 3, so minus 2 equals 0. And I could factor this to y plus 2 times y minus 1 equals 0. And so my points are negative 2 and positive 1. So this must be where y is negative 2, and this is where y is positive 1. So since it's this area with respect to y, so from negative 2 to 1, remember it's right minus left. So further to the right of this area is my curve, which is this formula here, 3 minus y squared, minus my line of y plus 1 dy. Well, I did say you could use your calculators, but we'll do it by hand just to practice. So we have negative 2, 1, so I have 3 minus a positive 1, so 3 minus 1 is 2. And then this is just minus y squared. This is just minus y dy. And so I'll integrate this guy first. So negative y cubed over 3. I'll do this guy. Minus y squared over 2. Plus 2y. And we're evaluating that from negative 2 to 1. And now be sure to plug in 1 minus, now plug in negative 2. When I cube negative 2, I get negative 8. And negative is just positive 8 over 3. When I square a negative 2, I get positive 4, so I still have that. And then 2 times negative 2 is negative 4. And I'll leave the rest up to you to solve. You should get 9/2. Okay, now let's look at problem number 6. I have my colored pencils ready. All right, so it says find the region bounded by the graphs, and they give us 3 graphs. So these are already in y equals form, so I can go ahead and graph them. So I'll do my x, y axis, and I guess let me use different colors. So this guy is 12 minus x squared. So it's 12 up here, right, because it's like negative x squared plus 12. And it looks something like this. And then I have the line y equals negative x. So I know that goes through the origin. I'll try to draw this straight as possible. There we go. Bring this down a little. And then we have y equals 4x. So that's going this way. So I have a general sketch, which I'm able to do without any points just yet. So now I need to find the region that is created by all 3 of these graphs. So let's identify this region. So all 3 graphs, well, 1, 2, 3. So this area, this area, this area. So this is an area here, here, and here. All this area on one side, and I'll use green for the other side. All these 3, 1, 2, this is all bounded here. Okay, so if I look at these areas here, right, this area in particular, I have the blue on top of the green, and here I have the green on top of the red. But if I look at this area as a whole, it's just this blue on top of the red. That includes all of these sections. So my blue, well, that's 12 minus x squared, and my red is 4x. So these 3 sections, all 3 sections, I can represent by using the blue minus the red. So I know over here this goes to 0. So I know my upper limit here is 0, and I need this intersection, right? Blue over red. So I need this point. So my blue is 12 minus x squared. And I'm going to set that equal to 4x so that I can find this point of intersection. And so if I add x squared to the other side, I have x squared plus 4x minus 12 equals 0. And then I'll go ahead and factor that. And I know this 6 times 2, so x plus 6, x minus 2. So I get negative 6, positive 2. So this must be my negative 6. Positive 2 must be on the other side. So this is negative 6. And so the blue is 12 minus x squared minus the red is 4x dx. So I'll use this to find this area, these areas right here, this whole shaded region. Plus, now I go to the other side. So on the other side, it's just exactly the other side. I have 1, 2, I have these 3 sections again. And so I can add these all up. If I add these all up as one section, I see it's this whole blue on top of the green. So I just need to know this point of intersection. I know this is 0, so I have 0. I need to find this point. So this is where the blue and the green meet. So that's these 2 equations. So I'll do 12 minus x squared equals negative x. So I have x squared, because I added that to the other side, minus x minus 12 equals 0. And so let's solve this. Here I get x minus 4, x plus 3. And so we have 4. So this must be 4. So I have 4. And again, what's on top here? The blue is on top of the green. So I have 12 minus x squared minus a negative x dx. And when you work these two out, you should get approximately an area of 106.7. So plug these in and make sure you get that. I hope this video helped.